Welcome everyone to this video by Learn Civil Engineering, where we will be working through a couple of example problems on the use of differential manometers to measure pressure differences within fluids. If you haven't already seen the last video on the use of standard manometers to measure pressure in a single pipeline, go and check it out as it covers the fundamental theory that we'll be using to solve these problems today. For the first problem then, we have a differential manometer used to find the difference in pressure between two separate pipelines. Two separate pipelines each convey a gas of density ρ. A differential manometer containing a manometric liquid of density ρm is used to measure the pressure difference PA minus PB between the point A in pipeline 1 and the point B in pipeline 2. This is done by connecting one end of the manometer to pipeline 1 at point A and then the other end to pipeline 2 at point B, as shown in the diagram. The pressure difference, PA minus PB, can be determined by measuring the heights h1 and h2. Show that PA minus PB is equal to ρm minus ρ times by h1 minus h2 times by g, and hence find the difference in pressure when ρ equals 1.2 kilograms per meter cubed, ρm equals 800 kilograms per meter cubed, h1 equals 58 millimeters, and h2 equals 176 millimeters. Pause the video here if you would like to attempt the problem before we work through it. Firstly, we must identify an elevation, which we will denote x, at which the pressure, Px, can be related to the pressures Pa and Pb. So we will take x to be the elevation of the lower interface of the manometric liquid in the right-hand side of the manometer. Therefore, in the right-hand side, we have Px is equal to Pb plus ρg h2. And in the left-hand side, we have Px is equal to Pa plus ρg h1 plus ρm g times by h2 minus h1. Equating these two equations gives Pa minus Pb is equal to ρg h2 minus ρg h1 minus ρm g times by h2 minus h1. And then simplifying this, we can show that Pa minus Pb is equal to ρm minus ρ times by h1 minus h2 times by g, as required. And then to finish off the question, substituting ρ is equal to 1.2 kilograms per meter cubed, ρm is equal to 800 kilograms per meter cubed, h1 equals 0.058 meters, and h2 equals 0.176 meters. This gives Pa minus Pb is equal to 800 minus 1.2 times by 9.81 times by 0.058 minus 0.176, which is equal to minus 925 newtons per meter squared. So the pressure of the gas in pipeline 2 at point B is 925 newtons per meter squared greater than the pressure at point A in pipeline 1. Moving on to the next question, we have an inverted differential manometer, where the manometric liquid lies on top of the pipeline fluid as the density of the manometric liquid is now less than that of the pipeline fluid. A pipeline conveys a liquid of specific weight gamma. An inverted differential manometer is used to measure the pressure difference Pa minus Pb between 2 points A and B, located either side of a constriction, which is just a point in the pipeline where the diameter is reduced. The manometric liquid has specific weight gamma m, and here the manometer is inverted, and so the pipeline liquid lies below the manometric liquid inside the tube. Hence, as described before, in this case we must have gamma m is less than gamma, or ρm is less than ρ. The pressure difference Pa minus Pb is determined by measuring h1, h2 and h3. Show that Pa minus Pb is equal to gamma times h1 minus h2 plus gamma m times by h2 minus h3. And then find the pressure difference when gamma is equal to 9,810 newtons per meter cubed, gamma m is equal to 0.8 gamma, h1 is equal to 23.1 centimeters, h2 equals 10.8 centimeters, and h3 equals 24.3 centimeters. Again, you can pause the video here if you would like to attempt the problem before we work through it. Firstly, we must identify an elevation, which we will denote x, at which the pressure, Px, can be related to the pressures Pa and Pb, taking x to be the elevation of the upper interface of the manometric liquid in the left-hand side of the manometer. Hence, in the left-hand side, we have Pa is equal to Px plus gamma h1, and in the right-hand side, we have Pb is equal to Px plus gamma m times by h3 minus h2 plus gamma h2. Then, eliminating Px results in Pa minus Pb equals gamma h1 minus gamma m times h3 minus h2 minus gamma h2. And by simplifying this like we did for the previous question, we can show that Pa minus Pb is equal to gamma times by h1 minus h2 plus gamma m times by h2 minus h3 as required. And then, to finish off, substituting gamma equals 9,810 newtons per meter cubed, gamma m equals 7,848 newtons per meter cubed, h1 equals 0.231 meters, h2 equals 0.108 meters, and h3 equals 0.243 meters, gives Pa minus Pb is equal to 9,810 times by 0.231 minus 0.108 plus 7,848 times by 0.108 minus 0.243 is equal to 147 newtons per meter squared. So the pressure of the gas at point B in the pipeline is 147 newtons per meter squared less than the pressure at point A in the pipeline. Well done if you solved both of these problems, and if you didn't manage to, I hope after working through them together, you now have a better understanding of them. This has been a video by Learn Civil Engineering. If you have found this video useful at all, please leave a like and subscribe to the channel to show your support. If you do have any remaining questions or would like me to cover a specific topic, please leave them in the comment section below and I will try to respond as soon as possible. Thank you for watching.